Hi everyone, today I'll share with you the solution of two questions which are about scalar product of two vectors. So let's begin the first one. Given model A equals to 2, model B equals to 5 and the angle between AB equals to 2p over 3. For what value of coefficient alpha will the vectors P equals to alpha A plus 17b and Q equals to 3a minus b be perpendicular? Firstly, we know that two vectors are perpendicular if and only if their scalar product equals to 0. So the vectors P and Q must be perpendicular, so their scalar product must be equal to 0. If we express these vectors P and Q in terms of the vectors A and B, we obtain that alpha A plus 17b times 3a minus b equals to 0. So let's simplify this expression. We obtain that 3 alpha a squared minus alpha ab plus 51ab minus 17b squared equals to 0. Let's combine like terms ab in this expression. So we get that 3 alpha a squared plus ab 51 minus alpha minus 17b squared equals to 0. We can write a squared as module a squared and respectively b squared as module b squared, which are equal to 4 and 25 respectively. Let's compute the scalar product of vectors a and b. We know that the scalar product of two vectors equals to the product of their models and cosine of angle between them. In this formula, alpha is the angle between the vectors a and b. Let's compute the scalar product of vectors a and b. It will be equal to 2 times 5 times cosine of 2p over 3. It will be equal to negative 5. So let's write these values in our expression. We obtain that 3 alpha times 4 plus negative 5 times 51 minus alpha minus 17 times 25 equals to 0. Let's simplify this expression. We obtain that 12 alpha minus 5 times 51 plus 5 alpha minus 17 times 25 equals to 0. Let's combine like terms 12 alpha and 5 alpha. The sum of these terms will be equal to 17 alpha. And if we add 5 times 51 and 17 times 25, both sides of the equation, we obtain that 17 alpha equals to 5 times 51 plus 17 times 25. To make it easy to compute this number, we can factor out the common factor. And in that example, 17 and 5 is common factors. So we can write this expression as 17 times 5 1 plus 3 plus 5. If we divide both sides of this equation, by 17, we obtain that alpha equals to 5 times 8, and it will be equal to 40. So this is our answer. Let's write the second question. Given the mutual perpendicular vectors P equals to S plus 2t and Q equals to 5S minus 4t, find the angle between the unit vectors S and T. According to the condition of this question, the vectors P and Q must be perpendicular. So their scalar product must be equal to 0. We can write P times Q equals to 0. Let's express the vectors P and Q in terms of the vectors S and T. We obtain that S plus 2t times 5S minus 4t equals to 0. Let's simplify this expression. We obtain that 5S squared minus 4st plus 10st and minus 8t squared equals to 0. Let's combine like terms, negative 4st and 10st. We obtain that 5s squared plus 6st minus 8t squared equals to 0. And we know that s squared equals to module s squared, and respectively t squared equals to module t squared. And according to the condition of this question, the vectors s and t are unit vectors. It means that their module equals to 1. So these numbers will be equal to 1. Let's find the scalar product of the vectors s and t. Their scalar product will be equal to the product of their module and cosine of angle between them. Assume that alpha is the angle between the vectors s and t. And the vectors s and t are unit vectors, so their modules equal to 1. So the scalar product of the vectors s and t will be equal to cosine of v, cosine of alpha. Let's write these numbers in the place of our first expression. We obtain that 5 plus 6 cosine of alpha minus 8 equals to 0. It will be equal to 6 cosine of alpha minus 3 equals to 0. If we add 3 both sides of this equation, we obtain that 6 cosine of alpha equals to 3, and if we divide both sides of this equation by 6, we obtain that cosine of alpha equals to 3 over 6. And if we reduce this fraction, we obtain that cosine of alpha equals to 1 over 2. And we obtain that alpha equals to p over 3. So this is our answer.